Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. For these two matrices A and B, we'll test whether the usual algebra rule, a plus b squared equals a squared plus 2ab plus b squared, still works. And then we'll discover the correct expansion term that belongs in the blank. First, combine A and B entry by entry to get the matrix we'll square. Now we multiply A plus B by itself. This is a real matrix multiplication.
Every entry is a row-column dot product, so we must be very clear about which row and which column we're using.
Let's label the rows of the left matrix and the columns of the right matrix. Then each entry is simply ri.cj. The 1, 1 entry is row 1 dotted with column 1. The 1, 2 entry is row 1 dotted with column 2. The 2, 1 entry is row 2 dotted with column 1. And the 2, 2 entry is row 2 dotted with column 2. Notice column 2 really is 2, 0 as a column. Putting those four dot products together gives the full squared matrix. Now we compute A squared. For this particular matrix A, it happens that A squared equals A. And for this particular matrix B, we also get B squared equals B. That's a special feature of these examples, not a general rule. Multiply in the order AB. Now reverse the order to get BA. The result changes. This is why the usual binomial shortcut breaks. You can't swap matrix factors freely. If we follow the incorrect 2ab idea, this would be the middle term. Adding a squared, 2ab, and b squared gives this matrix. Here is the true value of a plus b squared. And here is the number style expansion result. They are different matrices, so the familiar scalar formula does not apply. The safe way is to distribute without changing any order. Each distribution step produces one cross term, and the order is fixed. So the correct middle part is AB plus BA, not 2AB. The main lesson is that matrix multiplication depends on order. When you expand, you must keep both cross terms. Our computed matrices confirm the mismatch instantly. Next, we'll see more identities that do work for matrices, and how to spot when order will change the outcome. Watch the next video to learn more.